Okay, cool. So, welcome to the last lecture before the midterm. Really, even calling this a lecture is doing it far too much justice. The aim really here is just to prepare you for the test we'll have next week. So I've got three parts. I want to start by talking about the structure of the exam and a gentle reminder about how your overall grade is determined. And hopefully by doing that, I will put you a little bit at ease about the upcoming exam for this course. After doing that, I want to talk to you about what we'll do in the second half. In particular, I want to kind of set up why the second half is interesting in light of what we've done in this first 7 weeks. And then the bulk of our time today will just be reviewing. So that is going over any questions that people have. Really, again, trying to maximize this to make sure that you're as prepared as possible. So that's the plan. Let's talk first about the midterm. And first thing to say here is just a gentle reminder about how your grade is determined overall for the course. I don't really care where you get points from, but the points make prizes. That is, those are the things that determine your grade. So I'm looking at your top 10 homework assignments. Note we've had, I think, 6 so far, and there's a 7th one that you can do that's due next Monday. The 7th one is just the practice midterm. So, if you use the practice midterm, that's 2 more points. Importantly, you can get a max of 20 points from that, and then there's 80 points going between the midterm and the final. The midterm will be just on the stuff we've covered in the first half, so up till now. The final exam will only be on the stuff we cover in the second half of the course. So nothing that we're talking about, or that we've talked about for these first 6 or 7 weeks, will be on the final exam, except for one definition. You know what the definition is, and you already know what the first question of the exam is going to be. So I'll total all those points up. You get some score out of 100. I divide that by 10. I round to the nearest 0.5, and bang, there is your grade for this course, right? I say this because just preemptively, you can do very well in this course, even if you only get a 50% on the midterm. You get 20 out of 40 on the midterm, and as long as you keep doing the homework, you're doing just fine. Because to pass, you need 55 points or more. Obviously, I want you to do more than that. I would like you to succeed rather than just inch over the line, but it's helpful to know how easy it is in a way. So, yes, please.
On Osiris, will the rounded up points be there? Or
no. So Osiris is to 2 decimal places, but it'll be easy to figure out. Yeah. Yeah. Okay. With regards to the structure of the midterm, if people haven't already looked at the practice one yet, right? As I said, there's 40 points going. So it breaks down like this. There'll be 3 definitions to open. These are, much as they say, definitions. Right? And as a reminder, if you go back through the slides, the definitions are always in the blue boxes. Blue boxes, white text, the word we're defining is in all caps. So there'll be 3 of those. The only one that I will ask you specifically to get the wording of, you have to give me the definition of validity exactly in the right words. If you use any of the other definitions, as long as you got the idea, we're good to go. Yeah.
Can I show an example in the definition? For example, I know how to build this video and I will just show it. And a big words.
Yeah, kind of. So, I mean, you will need to at least broadly express you have what it is, right? So that means, to be honest, what I'm really looking for, with definitions that are about TFL, what's the magic word you need to be using? We need to use valuations, right? If we're doing TFL, mention that the stuff is defined in terms of evaluation. And if it's an FOL definition, interpretation, right? Importantly, if I have like, hey, give me the definition of logical truth, and you get it broadly right, but you mention valuation, it is wrong. That's important because these are different concepts. They're fundamentally characterized in different ways. So that's really the only sort of stuff I'll be picky about. Then there'll be 3 questions of analysis. These are the kinds of ones where I will ask you to use some concepts and then, hey, what can we say based on this information? So, okay, A and B are both tautologies. What can you then say about A biconditional B? That kind of thing. So there'll be 3 of those. Those are 1 point each. Then we'll have 6 questions for TFL symbolization. I'll give you a symbolization key and some sentences. You give me back those expressions recaptured in TFL. Then there'll be 7 points worth of questions with regards to TFL semantic notions. I'll explain that more in just a second. There'll be 2 questions of validity via truth tables. Again, more on that in just a second. And then finally, there's the sections on first order logic. I'll give you a sample FOL key, and you will need to symbolize some sentences into FOL. And finally, I will ask you to build your own interpretations to track various FOL semantic notions. So let's break this stuff down, specifically the TFL semantic notions and the FOL semantic notions. So first, the TFL stuff. I'm going to give you a sentence, and I will ask, build me a complete table. Easy. Then read from that table whether the sentence is a tautology, a contradiction, or neither. Then I'll give you a second sentence, and I will say, hey, is the first one tautologically equivalent to the second, yay or nay? Then I'll give you 2 collections of sentences, and I want you to tell me if those are jointly tautologically consistent or not. And for these questions, you get a point for the table and a point for reading the appropriate answer off the table. So, even if you just do the table and then screw the answer up, you still at least can get something. Yeah. 2 questions. 2 points each. Okay. And finally, what I'm going to do, I will give you 2 English arguments, and I will ask for you to use tables to show me if they're valid or invalid. So that means for these questions, this is exercise F, I believe, on the actual exam, you will need to build your own symbolization key, symbolize them into TFL, build a table, and then assess whether the argument is valid or invalid. 3 steps, 3 points. Symbolizing, table building, table reading. Importantly, failure doesn't cascade. If you mess up the symbolization, I will then evaluate whatever you've symbolized to see if it makes sense. Okay. Any questions on the TFL part before we go any further? I should also mention, obviously ignore the bottom part there. There's definitely nothing there. Okay, now with regards to FOL, I should say, sorry, a quick reminder about what I'm looking for here, right? When we're trying to show that a sentence is a tautology, we'll need to look at every row, and we need to make sure that, hey, that whole column under the operator, under the main operator, is all T's. But if it's false on even one, you know it's not a tautology. On the flip side, to show that it is a contradiction, it needs to be false in every row. If it's true even once, it's not a contradiction. To show that sentences are tautologically equivalent, they need to have the same truth value in every single row. If there's even one where they differ, then they are not equivalent. To show that they're consistent, just give me one row where they're all true. To show they're not consistent, there must be no row where they're all true. in that case, right? If it turns out that they are not consistent, you would need to give me a complete table. So every time where it says 1, you can get away with just 1 row. Every other time, you've got to give me a full table. And importantly here, everyone other than this top one, you can get away with some shortcuts and partial tables. If they're appropriate, sure. The only one where you need to draw me out a full table, fill out every single square with a T or an F, is that first question. Okay. Yes?
Even with the shortcuts, there is like oftentimes some sort of steps that we need to take. But if somehow we just look at it and think, oh, like I can tell, and write just a line of, is that okay?
If it's one of these ones where we can get away with just 1, absolutely.
Okay.
In fact, when I'm doing the answer key, that's probably what I'm going to do. My aim is to try and get everything on one side of one sheet of paper if I can. Okay, so that's the TFL stuff. I also, again, want to emphasize, look at how much of the exam is TFL. If you only know how to do truth functional logic and build tables, you will do just fine. And I understand and appreciate first order logic is a lot harder than TFL. So again, if you're struggling with FOL, sometimes it's worth making a business decision. The FOL section, on top of the symbolization, again, I'll give you a key. It'll be a very familiar key. You can expect to see our Viking friends again. I'll give you a key, and you do some symbolizing. But the interesting part will be the last section of the exam. The last section of the exam is where I'm going to ask you to make your own interpretations. And I'll first give you one sentence, and I'll ask you to show me that it's not a logical truth and not a contradiction. Then I'll give you a pair of sentences, ask you to show me they're not equivalent. Then I'll give you some sentences, ask for you to show me they are consistent. And finally, I'll give you an FOL argument. You'll show me it's invalid. This is the same stuff that we were doing, the exercises on pages 101 and 102 last week. It's one of each type. Yeah.
Jointly consistent or not jointly? Jointly consistent or not jointly?
Always jointly consistent, because we cannot show that sentences aren't jointly consistent. We don't have a tool yet to show the opposite. Here's what we can do with interpretations. You can do this stuff. So you can show that a sentence is not a logical truth. You give me an interpretation that makes it false. You can show a sentence is not a contradiction. You give me an interpretation that makes it true. You can show that two sentences are not logically equivalent by giving one interpretation where they differ in truth values. You can show they're consistent by giving me one that makes them all true, and you can show an argument's invalid by making the premises true and the conclusion false. Interestingly, we can't do the stuff where the dots are. That's what we're going to do in the second half of the course. Importantly, to do this stuff in the second half, we need to have a good grip on what we're doing now. It's different stuff, but it builds on what we've done so far. So, before we go anywhere else, any questions at all on the format of the exam? Do you understand what I'm asking of you? Feel okay? It's going to be fine, don't worry. So, let's talk about what's next. What are we going to do after the midterm? The second half of the course is going to build on and expand our logical toolkit. In particular, we're going to try and, one, add a few more tools that we don't have, and two, fill in those gaps. So first, we're going to have in lecture 8 a little bit of what I like to think of as the hangover lecture. Right? It's one where we talk about a subject that's really closely related to the formal material we've been doing, but isn't directly in there. And that will be really basic set theory. So the idea here isn't to teach you anything deep and dark about set theory, which could be fun, but not what we're going to do. It's instead to introduce you to some notation and some basic functions here, because these are the kinds of things you will run into later in life. And I want you to at least have some grip on what these functions are, what the notation means, so that when somebody just throws this at you, you at least have some hope of understanding it. So that will be what we'll do in lecture 8. We'll talk about basic set theory, and we'll talk about some properties of relations. So things like reflexivity, symmetry, and transitivity. The nice thing about lecture 8, there's no reading. It will just be me throwing some definitions at you, and then we can all go home happy. Lecture 9, we will get our third and final formal language. Importantly, it's really cheating to even call it an extra formal language, because ML, or modal logic, as we are going to be talking about it, is just TFL with 2 extra non-truth functional operators, our box and our diamond. And modal logic is specifically designed to capture sentences that TFL cannot capture, not properly. Modal logic captures modes of truth, and it encodes them into the sentences themselves. So for example, we've talked about the idea of necessary truths, and we can say that a sentence is a necessary truth, but of course when we do that, we're speaking the meta-language. We're not asserting something in TFL, we're asserting something in English. By adding the box to express necessity, we can now express it in TFL. We can say that a sentence isn't just true, but it's necessarily true within our language. And similarly, what the diamond is going to do is to let us say possibly. So we will drag some talk from the meta-language, from English, down into our formal language itself. And that will radically increase our expressive capacity. So that's what we're going to talk about in lecture 9. We're going to add these 2 operators to TFL to let us suddenly include modal talk into our formal systems. But the big fun starts at week 10, or lecture 10, I should say. Because lectures 10 through 13 are really where we're getting into the money for the second half. This is where we're going to get the tools to fill those gaps. These ones. And we're going to build to it, because the aim is to be able to fill those gaps for FOL. So specifically what we're going to do is we're going to learn how to construct proofs using what we'll call a natural deduction system. Natural deduction systems are a type of proof system governed by what we'll call inference rules, where you explicitly lay out the rationale going from some premises to a conclusion. What we're going to do is we'll have 2 lectures on natural deduction for TFL, and then we'll have 2 lectures of natural deduction for FOL. And we do it this way because everything we do here, we will repeat again for FOL. So basically, you learn to walk with the TFL, then we start running once we hit FOL. This is the real fun. It's so much fun to do. Importantly for us, it will then give us our complete formal machinery, because it will be, right, when we approach FOL, it won't just be interpretations, it will be interpretations and our natural deduction system. So we can then take an FOL argument. If it's invalid, we can construct an interpretation that invalidates it. And if it's valid, we could build a proof that shows how you go from the premises to the conclusion. That will be the big, big upshot. But again, this is all in the future. We got to get through the midterm first, right? So that's really what I wanted to cover today. As I said, it wasn't much of a lecture. It's really just designed to kind of say what the structure is, what we're going to do when we come back. The rest of the time I want to leave to do any review. Importantly, this means addressing any questions people have. If there are specific types of questions people want to talk about, anything like that. If not, that's no big deal, right? I'm happy to give you a little bit of a break between your marathons of lectures. What would be helpful to talk about? Please.
Doing at least one or two, more than one or two.
Sure. Okay. Yes.
If there's a free variable somewhere, this could also mean that it's algebra.
Good. So we can do this one very quickly. So the question was, what happens if we have a formula with a free variable? Right? So we have a formula that looks like this, say. So we've got a formula that looks like this. Is this formula going to be truth evaluable? Can it be true or false? No. It's not truth apt yet. And the reason it's not truth apt yet is we don't have a function that tells us how we're supposed to fill in this gap. The things to remember, right? This is very important. Variables look like names, but they do not function that way. They are just ways for us to label gaps. And until we have an associated quantifier, we haven't said anything yet. Until we attach one of these two to the front of the sentence, the front of the formula, say, we do not have a sentence yet. So the difference between a formula with a free variable and one without is that the one without is guaranteed to be a sentence.
So if you see somewhere a sentence and it has a free variable, you cannot explain if it's out or not.
It's just, it's not even said anything yet.
In the homework, at see which page it was, at page 101 and 102, like at D10,
Mm-hmm.
I'm not sure if you can find that, but I thought that was a free variable. So
Good.
I did not know, like, if I could actually explain it to you or not, because the answer sheet just tells me the answer, but doesn't explain why it's the answer. And I don't.
Is it EY, EZ?
Yes. Isn't why free variable then?
This one.
Yes.
There should be a quantifier here. We can just add that.
Ah, okay.
Or an existential, it doesn't really matter. But yes, there's probably a typo in the question there. There was a couple. Yeah, back in back.
You know the truth table?
I do.
Sometimes you don't have to fill them out.
Sorry, keep going.
Sometimes you don't have to fill them out completely. You just have to. How do you know the best way to find out the leads you have to do?
Good. Good. So this is why I included this big table here. It tells you exactly when you can get away with just part of it or when you can get away with all of it. Now the trick here is going to be, what is it you're looking for? If you're looking for, say, two sentences are not equivalent, easy thing to do, try and make one true and make one false. Think about what their main logical operators are. Right? If one of them is really hard to make true and one of them is really easy to make true, odds on you're probably going to be able to pull them apart. So you can kind of work backwards. Of course, that's not guaranteed to work. It might be such that after you go through a few attempts, it's just not kind of happening. That's maybe a time to just fuck it, go back, start filling in the whole table, and then see what happens. The other thing to note, and one where this will come up, is when you're checking for validity. So one of the things you can do to help yourself out is just focus on the valuations where the conclusion is false. So, draw up the big table, figure out in all of the valuations, when is your conclusion true and when is it false? Every one where the conclusion is true, set it aside, because that cannot be a problem. The problems, the threats, are ones where the conclusion is false and all the premises are true. So you eliminate the rows where the conclusion's true, only look now at the ones where it's false. Then we start going through step by step and seeing on the ones that remain, are there any cases where one of the premises is false? If any of the premises turn out false, you can also set it aside, because the threats are always true premises, false conclusion. So you can kind of help yourself out there. So more generally, when can you get away with short stuff? This will tell you. Right? How do you do the short stuff? Well, it depends on what you're looking for, but broadly recall the things that will be decisive. And just focus on those rows, or the rows that might get you to there. So again, a good trick, testing for validity. Put aside all the valuations where your conclusion's true, because that can't be a problem. That hopefully kind of narrows it down a little bit. It's not going to be a perfect option, because sometimes you have to kind of play around a little bit. The things to remember, keep this stuff in mind and you'll go far. The other thing to note, I want to stress, is there's lots of time. There's enough time here for you to be able to do the complete tables in every case. Draw them all out, draw all the T's and the F's in every possible case. You got 2 hours, and there's what, 31 questions, I think, right? And a bunch of them are definitions, right? You just, cool, those take like 15, 20 seconds, right? There will not be too little time for you to do all of the giant truth tables. And I'm not going to give you one that has like 6 different atoms in it. Right? I'm going to give you like a max of 5, and even that's probably not happening. Because I got to read them all, and I don't want to read that many truth tables. Okay, yes, sorry.
When we're writing our interpretations, are we allowed to like write things like A is not B, like as like a concern?
So I think, this is a good question. If we're building our own interpretations, how would we do distinctness, right?
Yeah.
How would we do like A is not B? The nice thing, if we're doing interpretations, I would suggest if you just have 2 objects in the domain, we will take them to be 2.
So do you take them as 2 different things?
Yeah.
I don't have to like.
You don't have to tell me they're different, right? In fact, we can say something here, and this will be generally true, right? We will presuppose distinctness if the 2 objects are listed in the domain.
Okay.
If you only had 1, you do this, and then you could tell me B is a name for A.
Okay.
So again, did everybody hear that? Right? If we're talking about distinctness and you want to have B is distinct from A, when you're building your own interpretation, you can just put 2 objects in the domain. I will take it to be 2 separate things. Yeah.
Like for some exercises, just indicating the domain is enough. And then
Sometimes.
they're not the same. So if they're not the same, this is enough.
This would be enough. This would be enough. Yes. Yeah, that's okay. That's okay. Again, this will be a kind of presupposition. If you list 2, I will take it as if you're saying they're distinct. You could go on, though, and say they're the same. That's fine. I mean, strictly speaking, the way we should express that would be to have one thing in the domain and then say this is a name for that object, but it's okay. Okay. Yes?
If you have a domain with A and B, you use a function, you use and so B, but you still have to connect B as well, or if it's a domain.
Sorry. So we've got A and B in the domain.
Yes, and you use a function, and you use a function with B, and would you have to write B as a name down as well?
Yes.
I also have a question. So my question is about your identity. There's how to directly translate. So I translate like this. There is something in the domain that is a wrestler, and everything, for everything, and every other thing in the domain that is also wrestler, also wrestles is the wrestler.
Good.
But does it mean that for all the people, like when the domain is people, this whole domain, there's only one wrestler?
Yes. Yes. So importantly, right, this is a good case. And this will bring us back to talk about the at least, at most, and exactly. So we'll quickly talk about those and then come back to your question. Right? So let's just use the F, right? We'll just use F's and G's as a very broad case. Right? How do we say there's at least one F? So that gives us there's at least one F, right? That's just what the existential says. Now, if we want to say there's at least two, right, we're going to need two quantifiers. We're going to want to say that they're both F's. And we have to make sure that whatever our two things are grabbing, they're grabbing different objects, right? So we need to say, and they are distinct. It is not the case that the identity relation holds. This clause ensures that our X and Y are different things from the domain. Okay. So this gives us at least two. Right? And at least sets the minimum number. So there's at minimum two. There might be a billion, but there's at least two. Now, when we talk about at most, we're setting the maximum. So how could we say there's at most one? We can negate at least two. This tells us there's at most one. It's not the case that you could reach into the bin and pull out two distinct F's. Either because there are none, or because there's only one. Okay. More generally, if you say at least n, you need to have n existentials. So at least 5 would be 5 existentials. And then a whole bunch of these pairwise distinct claims. If you say at most n, you are going to need n plus 1 quantifiers. The other way to do at most is you can say for any x and for any y, we'll go for at most 1 again. If you think that f and y are both f's, then you must have grabbed the same thing twice. If you reach in and you pull out an f, and you reach in and you pull out an f, then you must have just grabbed the same thing twice over. That's what this says.
So if you wanted to do these two, we do an extra one, and then these.
So if we want to do at least 2, right, we could take this, we add a third quantifier, we add another clause in here, and now what does our consequent need to look like? If there's...
X equals y and y equals z, x equals z.
Our consequent becomes a disjunction of the identities. So this tells us there's at most 2. Because if you reach in and you pull out what you thought were 3 f's, you must have grabbed at least one thing twice. Either the x and the y are the same, or the y and the z are the same, or the x and the z are the same. Or hell, maybe you grabbed the same thing 3 times. Okay. So again, for at least n number of existentials. At most n plus 1. Now, to come back to the, right? If we say the f, how many f's are there? There's exactly one. There's exactly one. Right? If we say the F, there is exactly one F.
So we can just push and sign between the two.
You can do it that way. The other way to go, right, is if we say the F, we're saying there's at least one F and there's at most one F. So this tells us there's at least one. And then we can also say, hey, for anyone, and this comes back to your question, right? For anything in the domain, if that thing is an F, then it must be identical to our earlier object. So this tells us there's at least one F, and there's at most one F. So if we were thinking of wrestlers, and we said the wrestler, right, what's the maximum number of people who could wrestle according to that claim? Just one. The expresses in English the definite. Right? It tells you there's exactly one. Now the trick here, and I take it this is the push for your incredulousness, right? Is it silly to think that there's only one person who wrestles? But we can figure that out by noting there's an implicit domain restriction. Most of the time when we say the blah, 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 we're saying within this very local context. But importantly, right, we're just aiming to capture the sentence. Whether the sentence is true or false is another thing altogether. So this is a way for us to say the. We say at least one, and at most one. Yes? There is no difference at all. Right? So you can put it, I'll write it in a cleaner spot. You can put this, right? You can put this. Either one of those is totally fine with me. It's just telling us that it's not the case this identity relation holds. The one thing you absolutely cannot ever do is this. This is a sin against God and man. Don't do that. Because that is ungrammatical. That's akin to leaving a free variable. We cannot do that. So no putting the negation in here before the second term. That doesn't make sense. Okay. Yes, please.
Instead of the negation x is equal, I can also do the x equals with the.
Yes, but please don't. Strictly speaking, no, because that isn't a symbol in our language. But I obviously know what you're trying to say. It's just better to have the negation up in front. Because we're using a language that doesn't have the non-identity sign as a special predicate. Yes?
We find out like in FL, the sentence wrestler and the sentence there's exactly one wrestler, right? So it's the same way.
It is the exact same FOL sentence, right? It would be this, just without the F, right? It would be a W. Because the wrestler and there's exactly one wrestler tell us there's at least one and at most one wrestler. There you go. Same thing.
Also, is every FL expression without regrettable sentence?
Yes. Well, okay. So let's correct that. Not every expression, every formula. Now the trick here is that remember, when we had TFL, we had that big box that gave us the definition of a sentence. This is 7 clauses. In FOL, we had a big box that was very similar to it, but it didn't give us a story about sentences. It gave us a story about formula construction. Formulas are our kind of middleman. Every formula without a free variable is a sentence. But an expression of FOL is just any string of these things. So yeah, sorry. So this is obviously not going to be a sentence because it's just simply failing at the base level of sentence construction. But if it makes it to formula hood and there's no free variables, you're golden. Okay. Yes, please.
Then how can we say that the dependent is this?
Nice. Good question. Good question. So let's think about that for a second. In terms of, let's use the F as the G, just because, right? So how would we say the F is the G? First things first, how many F's do we have? Exactly one. And how many G's do we have? If the F is the G, how many G's are there? There's only one, right? The is doing both words. So we'll say this. So this tells us there's at least one F and at most one F. So we have the F. And now we're going to want to say the G. There's at least one G and at most one G. But now, if we said that the F is the G, what are we trying to say? What's the last little bit we want to include here?
I feel like I have to do like X, G, X, but it is not grammatically correct.
So not quite. So let's think. If the F is the G, how many F's and G's are there? Just one, right? And who is it? Who is the F? Cool. The thing that is the G is identical to the thing that is the F. The is in this sentence is expressing identity. So what does this sentence tell us? There's at least one F. There's at most one F. There's at least one G. There's at most one G. So there's exactly one F and exactly one G. And they are the same thing. Oh, that's how we would do it. We say there's at least one of each and most one of each, and they are the exact same object. They stand in the identity relation to each other. Yes?
Is there not a simpler way to do this? It seems like a lot of work.
In a sense, yes, we could very quickly condense this down. Right? But the nice thing here is, and the reason why I suggest doing it this way, is it just takes the parts that we know how to do and links them up. If you know how to do the F, then you will also know how to do the G. So you can literally just string those bits along together. Yes, there is a simpler way. Here's a fun challenge. See if you can figure out what it looks like. Okay. So a couple things to mention that I would like to stress, right? And just as general kind of exam taking strategies. You probably already have this because you've made it to university already. One thing to do is to plan your time well, right? You don't have to answer the questions in the order that they're given. So start with ones that you might find difficult. Give yourself plenty of time to do those. If you get absolutely stuck on something, go to a different question. Go to a different section. You don't have to have everything written in perfect order, right? I'm going to go through them very carefully and try and find all your answers. Another thing to mention, and I will highlight this, is that the tutorials that we will have attached to Lecture 8, so the week after the midterm, will be partially talking about the new material, but it will also be an exam inspection. So I'll have the exams with me, I will hand them back to you. I'll put up the sample answers on the screen. And you guys double check my maths. Make sure that I added your points up, that I graded your answer fairly, these kinds of things. So again, there'll be time to double check things. If it's messy, that's okay. We have time to talk about it. You don't have to have perfect handwriting. It doesn't need to be in perfect order. I just want you to answer the questions well. Yes?
Is it 10 only?
Yeah, probably, yes. I think technically you can use pencil, but in this case it makes much more sense to do pen because pencils can be rubbed off.
Do we get, maybe this is in the cover page, but do we get a scrap paper?
Yes. Yeah. Oh, yeah. Good question. So there'll be scrap paper. You get a ton of paper when you sit down. So, and I always love. There'll be some people who do everything in like one piece, and then there'll be somebody who gives me like 20 pages. And I love that exam because it makes the stack go so much faster when I'm grading. Like you just take, oh my God, yes, one exam. It took out like a quarter of the stack. It's amazing. Don't waste paper, kids. But anyway. Okay, so are there other specific questions people have? Yeah, please.
I don't know if I can word this correctly, but when we're writing interpretations, and there are two variables, and we have to say that they can take this in this specific order. You mentioned like the arrows. I didn't quite get the arrows, but the way of writing it with these things.
Yeah, good. So this is helpful. If you're writing an interpretation and you're filling out the extension of a two-place relation, if you're writing out the extension of a two-place relation, you can't just give me a list of names. You need to give me what we'll call an ordered pair. So if we want to say that A loves B, we have to put that in the extension of L. Because this tells us, hey, the extension is this pair in this order. We can't just write, because this doesn't tell us who's the lover and who's the beloved. Yes?
Is there a way to write A loves everyone?
Yeah. How would we say A loves everyone? No.
That's simple.
No. But there's a really easy way, right? So here's a fun little quick and dirty exercise. What's an interpretation that makes this true? So if we have this sentence, right? For all x, LAX. What's a quick and dirty interpretation?
When L has, when in the domain of L is
Okay? So the extension of L, but it can't just be A, right? Well, no, it doesn't, not necessarily. So I get your idea, but we got to phrase it right, right? Importantly, what's the extension of our two-place relation need to look like? Yeah. It's got to be an ordered pair, right? It's got to be an ordered pair. And I think I understand what you were saying, right? We're going to make the extension of L that ordered pair. Well, that's a terrible angle bracket. And importantly, this is only going to count as everyone if we do one more thing. Well, we don't even need identity because A can represent itself. What's our interpretation missing? We got to have the domain. And what's our domain? Cool. Job done. Here's the other fun way you can do this one. Remember, guys, you can draw diagrammatic interpretations. There's a very simple diagrammatic interpretation that makes this true. Yeah.
Can we make all of these diagrams like A, B, and
Unfortunately, no. The diagrams only work when we only have two-place relations. Because we can't really represent three-place ones easily. You can, but it's difficult. And you can't really easily represent one-place predicates. Easily. You can, but it's just simpler to not do that.
I wonder if you don't use like that, the symbol, but like if you want to explain in the L
That it holds for everything?
like does everything? Do you need to write like everything in the domain, or
Yeah.
is there?
You would have to write everything in the domain. You would have to have the like angle bracket A, comma, and then a pair for every single object. It's annoying. But it is what it is. Okay. Any other questions? Please. How to go quickly? Oh, scope. Yes, absolutely. So the thing to remember about scope is that the scope of an operator is the sentence for which it is the main connective. So for example, in this sentence, this FOL sentence, what's the main operator? What's the main operator of the sentence? It's the existential, right? So here's a trick to tell. If you have a quantifier in the front and then brackets, the brackets are telling you what the scope of that attached quantifier is. How about this one? What's the main operator of this sentence? It's the conditional. So what's the trick here? Well, when we built this sentence, as it were, this is the operator we added last. We took this as a part, and we took this as a part, and we stuck them together Lego-wise with the arrow. So scope is a way for us to indicate, right, how did we build this? What was the connective we most recently added? And importantly, it's worth noting, are these two sentences logically equivalent? No, they are not. It's dirty, but they are not equivalent. To quickly see why, let's have a domain of A and B. Let's have F be B and Q be empty. On this interpretation, our top sentence is true because we can plug in A for X, make the antecedent false, which makes the embedded conditional true. Because remember, a conditional with a false antecedent is always true. But our second sentence is false because our antecedent here is true. There is something that's an F, but our consequent is false. It's a really nice case because the reason these are different is the scope of the two operators. The scope of the conditional here is the whole sentence. The scope of the existential in this one is the whole sentence. The difference in scope gives us a difference in truth value. It's a good question. Okay. Yes, please. Yep. Yeah. Well, if you only have one thing, yeah, it's going to be a bit fiddly because it's just either going to pick out a one object in the domain or not. So it still does something, right? It always works the same way. It's just, in this case, there's very little for it to pick between. No, you don't have to, right? It just depends on what you want. So here's another one, a very simple one. So here's an FOL sentence. Let's make an interpretation that makes it true. What's a very simple interpretation that makes this sentence true? Well, so x and y will never be in our domain, right? Because x and y are always variables. They only appear in sentences, never in domains. The only things that are in domains are objects or names. But let's think, right? What can we do here that will make this sentence true?
Name is A and then L, arrow thingy, A, without a comma, A.
Yeah. We could also do this diagrammatically. There's an easy way to go. Right? This one makes the existentials true. What is the x? A. What is the y? A. It's okay. Don't matter. Because all the existentials tell us is there's at least one thing in the domain. It could well be that there's only one thing in the domain. But to be true, it only needs at least one.
What if the negation of x equals y, then we need to add one more, like b and so, and do the work?
Yeah. Right? If we had this, and we also had the sentence, that sentence, right? What does this sentence, the second one, say? So, let's go. How many objects does this sentence require to be true? There has to be at least two in the domain. So let's just go, cool. Added another object into my domain, drew my arrow over to A. Or I could have left it blank. That's fine too. Because our first sentence just requires somebody else, somebody. And the second one requires there's two things in the domain. It don't say nothing about the second person telling anybody. Okay. So,
For this, how do we express this in structured thing?
for the one we just did,
Yeah,
we can go domain of A and B,
and they,
and the extension of L is A, comma, A.
okay, all right, perfect. We just added these to the domain.
Yeah, I have a question too, with the specific exercise that was homework.
Yeah.
So it was about that. It was, I had to show that something is logical consistent, those two sentences are logical consistent. And it was, let me just tell the exercise. It was a negation, existential X, universal Y, air XY. And then another sentence is universal X, universal Y, air XY.
Okay.
And yeah, no, I was not really sure how to do this because in my head it said there's not a thing in the domain that is yeah, I just didn't know how to prove that it's logically consistent.
Okay. So let's think what our first sentence says. Right? Our first sentence, if we ignore the negation for a second to make it easy. Take our first one. What does our sentence say without the negation? There's someone who loves everyone, right? There's somebody out there just sending all the love to everybody. Okay? So this tells us it's not the case that there's someone who loves everyone. Okay. Cool so far? So we know what this says. Now what's our second sentence say? Everyone loves everyone. Okay? So, let's think about this in terms of drawing diagrams, because we've just got relations. Our second sentence is going to require however many nodes we put. If we're going to satisfy the second sentence, what kind of arrows are we going to need?
Double arrow.
So A to C, and A to D, and A to B. What else is A going to have to relate to?
So
It's got to go to itself. And we're going to have to do that for every single one, right?
So can we put just like double arrow?
Yeah. Whole lot of ugly ass arrows. Okay. So we've made our second sentence true. Is our first sentence true or false? It's false. Cool. So, was the task to show that they're jointly consistent or that they're not logically equivalent?
That they are logical, consistent.
What exercise is it?
C.
Okay, let's look and see.
Because this is where I was like, how should I prove it?
Yeah, I mean, if it's written that way, it's going to be impossible.
But maybe I over the long run.
That's good to check. It's very possible that there is a typo. Oh, I see. It's not universals. It's this one, yeah? Number 10?
Yeah.
Can you repeat the phrase?
It's that one. That makes more sense. That. It's an existential. Says something very different. Yeah.
Can you address
Sorry, hold on. There's two things. What'd you say?
we can't see.
Oh, yeah. Here, let's do this. Give myself some space. So it says this. So here's our two sentences. I think this is probably what it was. We just made a mistake slightly on the writing it in. So our first sentence, again, without the negation, there's somebody who loves everyone. So this tells us it's not the case there's somebody who loves everyone. What's our second sentence say? Everybody loves someone. Right? So now, how can we draw a diagram that's going to get this to come out true? Let's take our second one. How can we get it such that everyone loves someone? Well, that's the other way around, actually. That's there's someone everyone loves. But we could do it that way too. So let's have A, and let's have B, and let's have C. For each person, is there someone that they love?
Would it be also correct to point it out yourself?
Yeah. I mean, that's a horrible state of nature kind of thing, but sure. Everybody loves somebody. They're all selfish bastards. Right? Importantly, is our second sentence true? For each person in the domain, is there something that they love? Is there someone that loves everyone? So there we go. Right? We can make them both true.
How to write the basic domain?
Good. So let's think. How would we do this if we were going to write this down? So in this case, we've got three objects in our domain.
Oh, A and A, B.
And then our extensions are going to be, Oh, sorry, no. I forgot we did it this way. There we go. You can do it this. You can do it this. Either way is fine. Okay. So we'll wrap up. I want to stress a few things again. Screwed up the recording, but that's okay. I want to stress first, this is just an exam. It's not the end of the world if it doesn't go well. There's a resit for the midterm alone in December, which will just be on this material. So even if you don't do well or you can't make it or something happens, don't freak out. It's going to be just fine. Second thing, as I said already, the first tutorial after we're back from the midterm will have an exam inspection. So you'll be able to look at your sheet, your answer sheet. I'll give you the sample questions. I'll give you the sample answers. You can evaluate, make sure that you were graded fairly and justly. The last thing to say is yeah, just have fun with it, right? You've learned all of this stuff. You guys have done really, really well so far. So just go to it. We'll talk about the practice exam during the tutorials this week, and I'll put up some sample answers for them probably Thursday afternoon to give people plenty of time to kind of go through them. But yeah, hopefully see you in the tutorials later on. And good luck with all of your exams in the next coming weeks. Take care, guys.